Welcome, everyone, to First Principles Podcast. We are your hosts. This is Trees, and I'm joined by
Elliot.
My brother Elliot. And today we're going to be continuing off of the theme of energy and specifically renewable energy, how to incorporate batteries into renewable energy. If you've been following us for the last several podcasts, this has been the prevailing theme, and we're going to continue down that direction and focusing on the battery storage side of things, the energy storage side of things more broadly, and try to look at different battery or energy storage mechanisms that are out there that exist. And this is specifically for large scale power generating facilities, right? The whole notion, just to remind everybody that might have missed the previous episode, is from the idea that when we are incorporating wind and solar into the existing electrical grid, this is not sufficient. We need to also add storage because the sun isn't always shining, the wind isn't always blowing. So for those moments, we need to have energy stored. So much like a battery, we can use it upon request. I'll let you jump in there, Elliot, with some thoughts.
Yeah. How do you make unreliables reliables? And I think a good place to start when we want to take a look at what is the current state of energy storage technologies is, let's go online and see what, the mainstream media is reporting on. And so that's what I did. I went on and, I found a clip from CNBC. This came up within one of the top results, when you type energy storage in to Google. Google algorithm spits out this, and this clip was called "The Future of Energy Storage Beyond Lithium Ion." It came out on March 13th, 2020, and it had over 2 million views, 2,355,000 to be exact. Let's just jump into this first clip here.
Okay, clip number 1.
We need a good way to store energy for later, and the main option right now is lithium-ion batteries. You see them in products like Tesla's home battery, the Powerwall, and utility-scale system, the Powerpack. But though lithium-ion is dropping in price, experts say it will remain too expensive for most grid-scale applications.
To get to battery for the electrical grid, we need to look at a further cost reduction of 10 to 20x.
Right now, lithium-ion batteries just can't store more than 4 hours worth of energy at a price point that would make sense. Plus, they pose a fire risk, and their ability to hold a charge fades over time. To address this, there's a cadre of entrepreneurs experimenting with a variety of different solutions.
Now we're seeing flow batteries, which are liquid batteries, and we're seeing other forms of storage that are not chemical or battery-based storage.
And each has serious potential.
Well, okay. So what do you think of that music in the background?
It's pretty distracting. I don't know.
I agree. I do not like it. I just see a lot of news reports that come in this form have that. And maybe it's a YouTube thing, but it's like a little hopeful beat in the background that it's
No, I'll tell you exactly what it is. It's just people think that people have very short attention spans, so we got to have some flashy music in the background so that there's something else for the subconscious to think about before you lose your focus and get bored. That's what it really is. My thoughts, anyways. Maybe the cynic in me.
Well, no, I would agree, and it is actually it's funny because even the format of having your reporter narrator talk and then snip in these audio clips from these experts with them saying one or two lines that, confirm what you're saying is a very common way of presenting information. And it can be a bit misleading. But let's go back to that clip there. So she talks about, the concept is lithium-ion technology for battery storage is great, but it's got some problems and limitations, she's saying. And there's some other technologies coming out. So she is talking, this piece was put together, and they interviewed a number of experts. So I'm going to go over a few of these experts here. So we had William Chow. He was an associate professor in material sciences and engineering at Stanford University, or is, I should say. And he was the one that came on early in that clip and said, to get batteries for the electrical grid, we need to look at a further cost reduction of 10 to 20 times. Now, he says batteries in general. The assumption could be made he's talking about lithium batteries specifically, but there's other forms of batteries that are being used for a large-scale application or energy storage application in general. It doesn't need to be large-scale. But he's saying there's a cost hurdle we need to get over. And this is, okay. And then he goes on to say, it's actually another professor. So this is Dan Carmen, professor of energy at the University of California, Berkeley. He says at the end there, now we're seeing flow batteries, which are liquid batteries, and we are seeing other forms of storage that are not chemical or battery-based storage. So he's talking about flow battery technology, which are liquid batteries. And this is there's going to be 3 types of technologies that are outlined in this news clip. And the 3 are flow batteries, gravity-based storage system, and thermal-based storage system. And so beyond these university professors, they also interviewed these CEOs of specific technology companies that are focusing on, developing one of these systems. So they have this guy named Tom Steffen. He's a co-founder and CEO of a company named Primus Power, and they're focusing on flow battery systems. And then there's another guy named Rob Pinocchi. I might be butchering his last name. He's a co-founder and CEO of Energy Vault, which is a gravity-based storage system. And then there's Justin Briggs, co-founder and CTO of Antora Energy, and they're focusing on thermal energy storage. Now, I say all this because we're going to go into a further clip from that same report, and it will explain what these different systems are, so don't worry. But just a little bit of background before we go to the next clip. If you want to go to the next clip, go for it.
Yep. So clip number 2.
We know today that solar PV and wind are the least expensive way to generate electricity.
In particular, the price of solar photovoltaics has plummeted far faster than all forecasts predicted, after China flooded the market with cheap panels in the late 2000s.
All the Wall Street analysts did not believe that solar was going to ever stand on its own without subsidies. Well, a few years later, even the most conservative analysts started realizing that actually solar was going to become economic in most parts of the world pretty quickly.
And as solar's gotten cheaper, so too have lithium-ion batteries, the technology that powers electric vehicles, our cell phones, and laptops. And thanks to improved manufacturing techniques and economies of scale, costs have fallen 85% since 2010. Now, wind or solar plus battery storage is oftentimes more economical than peaker plants, that is, power plants that only fire when demand is high. Tesla, for example, built the world's largest lithium-ion battery in Australia, pairing it with a wind farm to deliver electricity during peak hours. But this doesn't mean lithium-ion is necessarily economical for other grid applications.
We don't really see the cost structure coming down to the point where it can serve those tens to hundreds of hours applications.
Basically, the market is ripe for competition.
Okay, so
before you say anything,
Yeah.
I just want to say I fucking hate that music so much. So much.
it really gets on your nerves.
Wow.
Yeah. Yeah.
Sorry, go ahead.
No, I feel you. So the clip begins with a quote from Tom Steffen, this co-founder and CEO of Primus Power, which, like I said earlier, is a flow battery system company. That's what they're trying to make their money off of, right? And he says, we know today that solar PV and wind are the least expensive way to generate electricity. Mm-hmm. And I want to say this is very likely BS. And you want to talk about that more? Maybe go back to our last episode and the last 2 episodes, and you can get more information on that. But I look at this character, and I have to say, he reminded me of David Icke. You know David Icke, the English conspiracy theorist guy?
Yeah, yeah.
His cadence, the way he his hands were moving and everything, I was like, this is a salesman. This is absolutely a salesman. He knows how to tell a good story, and this is the story he's telling. But, you know, there's a lot of reasons why, you know, electricity being generated from PV and wind have come down, and it is getting cheaper. But just to straight out just say it is the least expensive way, you know, who knows where? And he might have actually said more. He might have expanded on this. Again, though, we're just getting a clip of it for this report. So it is what it is.
So either he's greasy or whoever produced the clip is greasy.
Exactly.
Somebody's got some oil.
Someone's got some oil.
Got that Pam. Huh?
And the next thing that I noticed is, so they start talking about, you know, nobody thought PV would stand on its own without government subsidies. And until China rolls out and manufactures a bunch of these PV and floods the market with these cheap, you know, solar panels. And this is a concept that I'm trying to still work out here, but it goes back to, can we actually sustain this? Like, if we were relying on superpowers that we know burn coal as their primary way of generating electricity, that forgo certain policies and human rights and just general wages, you know, proper wages and such for their workers, to generate cheap solar panels so that we can build affordable economic, you know, energy grids in the West, is something a little off to me about that. You know, it's like, okay, yeah, good job. We showed that we can actually make things very cheaply.
It's like this faux sustainability. It's like we want to look at it as being sustainable, but it's not. We want to think it's renewable, but it's not. It's just the facade. That's just what we're sold without getting that broader picture of that cradle to grave analysis. You'll hear that frequently nowadays. Maybe not so much in the media, but you often want to do a cradle to grave analysis, which means from start to finish, look at the impact of your product, not just during the use, not just during the production, not just in the end during disposal, but throughout the entire life cycle. And that was actually one thing that did stand out to me with that clip, was that he's saying that, okay, China flooded the market, okay, and that's what led to a decrease in cost. But it still negates that there were still subsidies used. It's not like they're mutually exclusive. Yeah, China flooded the market, but subsidies were still used. You bet your ass they were used. Which we mentioned actually during our last episode, which we talked about some of the subsidies that was used specifically in the Ontario government in order to guarantee fixed rates that the government would pay to producers of electricity that was made via wind or solar, right?
Yep.
So when you're talking about like subsidies, like
they did play a role at the end of the day.
Yeah, exactly. Just in the reverse way. But yeah, so all that to say that subsidies and China flooding the market are both at play here if we're going to look at the reduction in costs. But to say that it's only from China, they're not mutually exclusive. There's subsidies and there's China. So yeah, that was an interesting point that I just wanted to bring up there.
Sure. Yeah. And the clip ends with the reporter saying, or she's talking about Tesla building the world's largest lithium battery combined with wind turbines in Australia to supply electricity for peak hours. And she was saying, you know, this system kind of perhaps proved that there's cheaper ways with renewables to produce peak energy, instead of using peak plants that were like gas powered and such, fossil fuel based, right? But then she goes on, but there's limitations with lithium ion, you know, when it goes to other scripts.
Yeah, they run for 4 hours.
Exactly.
It's cheaper to do it for 4 hours. Oh, okay. Well, is that practical? again, like we had these people make these statements. Oh, this is a cheaper alternative. Okay, for 4 hours. So what, you're gonna build a plant that runs every 4 hours, or you got like stack of batteries so it cascades, or how's this actually gonna work?
And I would say that it was actually, the report is critical of lithium ion, rightly so, for that the exact reason. It has its limitations on these grid, providing power for long periods of time after it's been stored. That's where these lithium-ion batteries fall short. And then she goes over to a quote from Justin Briggs, the co-founder and CTO of Turner Energy, and he's the one trying to focus on doing thermal energy storage. That's a business model he's basing his career around. And he says, we don't really see the cost structure coming down to the point where it serves those those tens to hundred applications. So it's very out of context, this quote, and I'm like, is he talking about lithium ion, or is he talking about his own application? Because he's a specialist in thermal energy storage, not lithium ion. But so my critique has been, and it will be throughout this report, is the experts that are critiquing the other the other technologies are guys from a company that are pushing a new type of technology, right?
It's the competing guys.
Yeah, competing guys.
Obviously, they're gonna be shitting on the other guy.
Of course, that's what I was like. I'm like, okay, yeah, but of course you're gonna shit on the other guys. Like, come on,
let's be real.
Yeah,
yeah. And sorry, where did you source this clip from?
This is CNBC.
Yeah, CNBC. Yeah, good job, CNBC, getting an unbiased source there.
Yeah.
Like, for your freaking news.
Like, at least have the engineering professors comment on it, not the guy from the other other company. But even there's issues.
Like a neutral source as well. But anyways. That's too much to expect these days, guys. Who's kidding who?
Yeah, who are we kidding? So just let me recap there. So there's 3 types of energy storage in a broad sense. They talk about flow battery storage systems, gravity-based storage systems, and thermal energy storage. But what the heck are each of these things? So let's go into clip 3, and she'll tell us what they are about.
All right, clip 3 coming up.
One of the main alternatives being explored is a flow battery. Unlike lithium-ion, flow batteries store liquid electrolyte in external tanks, meaning the energy from the electrolyte and the actual source of power generation are decoupled. With lithium-ion tech, the electrolyte is stored within the battery itself. Electrolyte chemistries vary, but across the board, these aqueous systems don't pose a fire risk, and most don't face the same issues with capacity fade. Once they scale up their manufacturing, these companies say they'll be price competitive with lithium-ion. But for all their potential, flow battery companies like Primus and ESS Inc. still aren't really designed to store energy for days or weeks on end.
Many of those flow battery technologies still suffer from the same fundamental materials cost challenges that make them incapable of getting to tens or hundreds of hours of energy storage capacity.
Other non-lithium-ion endeavors, such as the MIT spin-off Ambri, face the same problem with longer duration storage. Form Energy, a battery company with an undisclosed chemistry, is targeting the weeks or months-long storage market, but commercialization remains far off. So other companies are taking different approaches entirely. Currently, about 96% of the world's energy storage comes from one technology, pumped hydro. This system is pretty straightforward. When there's excess energy on the grid, it's used to pump water uphill to a high-elevation reservoir. Then, when there's energy demand, the water is released, driving a turbine as it flows into a reservoir below. But this requires a lot of land, disrupts the environment, and can only function in very specific geographies. Energy Vault, a gravity-based storage company founded in 2017, was inspired by the concept, but thinks it can offer more.
And so we wanted to look at solving the storage problem with something much more environmental, much more low cost, much more scalable, and something that could be brought to market very quickly.
Instead of moving water, Energy Vault uses cranes and wires to move 35-ton bricks up and down, depending on energy needs, in a process that's automated with machine vision software.
We have a system tower crane that's utilizing excess solar or wind to drive motors and generators that lift and stack the bricks in a very specific sequence. Then when the power is needed from the grid, that same system will lower the bricks and discharge the electricity.
But some say the sheer size of the operation means it just can't be a replacement for chemical batteries.
Sounds very simple, However, the energy density on those systems are very low. And so that's where we believe chemical-based storage still has an advantage in terms of a footprint. You can't install a gravity-based system in the city, but you'd have to install it outside in the remote areas.
Then there's thermal storage. It's still an emerging technology in this space, but it has the potential to store energy for longer than flow batteries, with a smaller footprint than gravity-based systems. Berkeley, California-based Antora Energy, founded in 2017, is taking on this challenge. Basically, when there's excess electricity on the grid, that's used to heat up Antora's cheap carbon blocks, which are insulated inside a container. When needed, that heat is then converted back into electricity using a heat engine. Typically, this would be a steam or gas turbine, but Briggs says this tech is just too expensive and has prevented thermal storage solutions from working out in the past.
All right, that was a bit of a long one, but they did an all right job of covering each of those different energy storage systems. I thought it was interesting. I had this gravity-based storage system. She points out at one point that it's one of the more common ones used, where you basically pump water at a lower elevation up to a higher elevation when you have the excess energy, and then you let it flow back down again through a turbine to regenerate that electricity when you need it. And then it goes on to point out one specific type of company that they have a visual of this. They are essentially have a crane, stories upon stories high, and they are taking concrete blocks and just like literally making a tower out of them when they have the energy, and then taking down that tower on like a pulley system that then as it's falling, that brick mass, it's pulling the pulley, and this pulley is turning the turbine and generating the electricity. Never seen anything like that before.
That's new to me too, for sure.
Bizarre. But it begins with this comment. It begins with, it talks again about the fire risk of lithium ion batteries. And yeah, I've heard about the risk of, fires with lithium ion batteries, but it seems to be like a reoccurring theme and like kind of like a jab at what the issue with lithium ion is. And I was like, isn't really a fair criticism based on all the risks that are associated with all these other storage technologies and just the general accepted risks that are associated with power generation, that you point out lithium ion and the fires associated with them? Like, it just seems to me it's a weird one that they've keep repeating about, well, that's the problem with lithium. Well, there's other problems with lithium, but why are we focusing on just the fire risk of it? And not really clearly outlining, well, what are the other risks associated with these other technologies that are out here? It was just a weird, I'm like, is this a jab at Elon Musk and Tesla and like what they're doing, or is this just some bad investigation of like what are the downsides to lithium ion?
Because there's ways of, just jump in there, there's ways of doing lithium that essentially takes care of those issues of combustibility or like random explosions taking place. So there are chemistries, so this involves using slightly altered chemistries, which is what batteries are, but taking advantage of different chemistries that you can incorporate that would alter this phenomenon or reduce the probability of this phenomenon taking place. So even though it might be valid in certain cases, it still negates the fact that there are solutions that already exist for that issue.
Right. The other thing I want to point out, and it was mentioned briefly, and I caught this on my second listen, but they mention a company called Form Energy, which is developing flow batteries with this is the quote, undisclosed chemistry, which is targeting, making batteries that provide discharge for like the weeks to months based storage systems. But they say, commercialization remains far off for that company. And I bring you'll hear about this company in my second clip, but they do mention this one. And the other part of this, well, I pointed out this out earlier, but every time you heard somebody criticizing the other one, it was a guy from another company that's doing something else throughout that.
Everybody's selling their own thing. That's the moral of the story there.
Yeah.
Everybody's got something to sell, so if it sounds great, but What are they trying to sell you that they're not telling you about?
And everything sounds great theoretically, but throughout it, it's just like none of this stuff is proven yet. And it might work on a small scale, but can we really get this stuff to work larger? But there is a greater toolkit to use, and I like that. And I like that there's some other options to consider out there. It's all based around batteries, and that's worth mentioning here. But let's skip over to this next video, which again, it was one of the top search results from Google, and of course it's from Bill Gates. This one is called Energy Storage Breakthroughs, and this was actually less popular in terms of views, and it's a little older. It's from May 14th, 2019.
Wait, just out of curiosity,
Sure.
there. So that clip, we've gone through the clip, and was there any mention in that clip of hydrogen storage?
Oh, you are smart, aren't you? Let's, no, there was not. There was absolutely not. And let's listen to what Bill Gates talks about and see if he brings up this amazing thing called hydrogen.
Okay, we'll put a pin on that and continue about that. Okay, let's listen to this clip.
Wind and solar power generation is expanding, but one challenge we face is how to store that energy when the sun isn't shining or the wind isn't blowing. Here are 3 innovative companies searching for breakthroughs to solve this challenge.
For the first time ever, renewable power is cheaper than fossil-intensive fuel sources. I mean, that's a remarkable statement. Malta's mission is to enable the supply of reliable, resilient, and affordable electricity anywhere in the world. And we're doing that by developing an energy storage technology that is long duration and cost competitive. The Malta system is very simple. On the front end, as the electricity comes in, it basically operates a heat pump. What you're doing is taking the hot side and storing that in molten salt. And salt stores heat very well. And you're taking the cold side and storing that in an antifreeze solution. And then when the electricity is needed to go back out to the grid, what you're doing is basically reversing that process.
QuickNet is taking the largest form of energy storage today, which is called pumped hydro storage, effectively running water up and down a hill. And we're just bringing that to regions where there are no hills and it's all flat terrain. For pumped hydro storage, the majority of the cost is building the dam and constructing on the side on the top of a mountain. With QuickNet's subsurface geomechanical pump storage, we take that cost and bring it down about an order of magnitude. QuickNet facility essentially involves a surface pond, a mechanical room, and a well. When the system is charging, water is pulled from the pond and pumped down into the well and kept at high pressure. When we're discharging, the high pressure water is allowed to come back up through the well, flowing through the turbine and back into the pond.
Form Energy's bidirectional power plants are quite different from other kinds of energy storage. Lithium-ion is the one that most people know, whereas lithium-ion batteries are fantastic sprinters. You would never take a sprinter and ask that sprinter to run a marathon. In our case, what we are going after is a very different kind of race. And that marathon racer is a different electrochemical challenge to smooth out those intermittencies over long periods of time, days, weeks, or potentially even months. The bidirectional power plant operates under the same principles that any energy storage device does. You have a source of charging, and then it's discharged according to the value maximizing algorithm that we have developed. We use earth-abundant elements, and we use elements which are non-toxic and very benign.
All right, so hydrogen mentioned there?
Nope.
I thought this was odd. I was like, I got to the end of both of these videos and I was like, but wait, what about hydrogen? Like, why is this not mentioned? And, going back to our previous podcast and basically, pointing out there's so many places in Europe that are using hydrogen for energy storage. Like, this is not an unproven technology. Just why is it not here as being discussed? Is it simply because it's not new? Well, it is kind of new to the U.S. and Canada, so I feel like it should be fairly mentioned. In fact, of the 3 categories, it's kind of its own thing, and yet no discussion from CNBC about it, no discussions from Bill Gates in these two clips. Now, they might have touched on this in other reports, but this is what it is. These are your top results here, okay? The companies that they highlight go over the same three energy storage systems that was discussed in the CNBC. Malta there was doing the thermal-based system, which was pretty cool. You know, they had the heat pump, and they're using the heat side to be stored in salt and using the cold side to be stored in antifreeze. There was the...
I have a question about that. Is that mostly for heat, though? So would that actually be generating power, or would that be just heat?
No, it's for electrical. So the heat pump would... I'm not a specialist in heat pumps, but basically the idea would be through the movements of the heat, the transferring of it, it is in fact turning something that generates electricity, and they're going back and forth on that. The QuidNet energy is using the gravity-based system, which was not a crane and not pumping water up to a higher elevation, but taking water at like a normal elevation, your pond water at the surface, and pumping it into the ground at high pressures, and then when you need to pull water out of the ground again, you just open the valve and the water shoots out because of high pressure, comes back up the well, and it powers the turbine. So he was saying this actually brings down the cost of this. Instead of you having to build this big channel that goes up and down, or use geology, like having hills and stuff near you to have the system available, you could just, drill a well, put your water with high pressure down, bring it back up, was the idea. And then the last one, which is Form Energy, which is mentioned in the CNBC one. And this is that battery system, that flow battery system that has that proprietary undisclosed chemistry. And they're trying to tackle, batteries that can provide storage for larger utility scales. And I bring this up only because it kind of highlights the difference in approach of the technologies. Like Energy Form, I'm assuming they're trying to keep this as a trade secret. Basically, they don't create a patent for it. They just keep it all under lock and key. Nobody really knows what their formula is in the attempts to have something that might have an edge in the market. But it was, I thought that was interesting. And I don't know, any thoughts from those clips?
I think, my main thought is that these seem pretty promising. These are interesting storage technologies, and it makes sense. Like for example, using the water in a pressurized well. I've heard of that. That's been done. Or for example, these thermal storage systems. I've heard of that as well, and it's been done, and I just wish that we'd have more development of these. And it's just my question, I guess, comes back down to cost, and what is the cost of these? And these things have been known for a while, like these technologies. I remember in undergrad hearing about pretty much all these except for that brick one, or like that one where it's like boulders or whatever coming down
off the crane,
the crane, which doesn't sound very scalable, to be honest. I don't know. It sounds like you can get like a pretty good amount of power, like for like your house. I don't know, like with something like that. I don't know, but my main thoughts are that why is hydrogen not mentioned when it's probably the oldest technology out of all of these, if anything, and it also has the most promise, because it's similar to electricity in the sense that it's a secondary energy form, right? Electricity comes from the primary form of nuclear or whatever it might be, right? So when we look at primary energy, we have, for example, a gas power plant. We have nuclear power plant. We have our solar. So that's a primary energy. But then the primary energy from those is converted into a secondary energy, which is a storage, in order to get it to your final form, which is light or whatever, this microphone that we're talking into. But I just want to highlight that point, is that it's a secondary energy storage, is what electricity is. And that's what hydrogen is as well. It's a secondary form of energy storage. None of these other ones are, these other ones are kind of secondary in that sense as well, but they do lack that transportability aspect of it. Like hydrogen can be moved around. These things are more
stationary.
So to me, that's just another benefit that you get from hydrogen as well. And not only that, but it adds a potential vehicle infrastructure that you can use for transportation. So that's another benefit that you could get, where you could develop a potential grid, a vehicle fleet that's based off of hydrogen-powered vehicles, which you alluded to earlier in the episode. But Toyota in Japan is really at the forefront with the Toyota Mira, I believe is what it's called. And they have, I believe, they're on the second or third generation right now, and they made a lot of developments of it. But one of the things that's lacking is the hydrogen grid, or the infrastructure necessary in order to refuel. Because if you have a vehicle, you're going to need to refuel eventually. Well, it's kind of like a chicken and egg scenario. Do you get the vehicles first, or do you get the grid first? Right? So there's another huge benefit associated with hydrogen, but which you don't get with any of these, as I see. And again, it's out of the picture. Why? I don't know.
Why is it out of the picture? I don't have an answer, but let me speculate in two different areas.
Okay.
First, is it safety related? They're focused on the exploding, lithium fires and stuff like that. Hydrogen has some safety issues with it, but is this why they're not mentioning it? Or is it that Bill Gates and Elon Musk do not have a horse in this race?
Bingo.
I think that might just be the reason right there.
Let's be real. Yeah, that's really what it is. Like, they're not pushing it because they don't got a stake in it. Like, let's be real. They're not pushing it because they don't have a stake in it. They don't have money in it. So why are they going to push it? It's unfortunate to think in those terms, but you've heard Elon Musk actively say that he doesn't like hydrogen. He thinks it's dumb, it's stupid. But meanwhile, it holds so much potential, which is, many researchers have spoken about the potential of hydrogen and the development that it needs. But yeah, I don't know.
Yeah, and I have some clips on Elon's criticisms of hydrogen, but I have those. That will be in another podcast there.
Okay, to be continued.
So let's now look at a TED Talk, a TEDx talk. This was done by Tom Garr, and it was called Energy Storage, the Key to Clean, Reliable Electricity for Everyone. Now, Tom Garr is the Director of Research and Development at the Organic Energy Storage Laboratory at Michigan State University Biochemistry Institute, Holland. His current research is focused on using organic materials for various types of electrical energy storage. In 2015, he co-founded a tech startup, Jolt Energy Storage Technologies. Jolt Energy's concept for organic redox flow batteries empower utilities to bring more new renewable energy resources onto the grid. I bring him up. I find him an interesting speaker, and I like a concept of a large-scale flow battery that is made up of materials that are more environmentally friendly in terms of not needing them to be mined from different countries. Is it a possibility that this is actually possible to develop a flow battery that can be used on the grid scale that doesn't contain cobalt, lithium, but relies more on salt, water, and some organic materials? This could be a pipe dream, but I thought his comments on this whole situation were interesting. So let's take a first clip look at his first bit of his TED Talk here.
Okay, clip number 5 coming up.
So for those of us lucky enough to live in an area where we have reliable electrical power, where does it come from? Mostly it comes from burning stuff. In the US, about 1/3 of our electrical energy comes from natural gas. About 1/3 comes from coal, and yes, we still use coal, and no, there's no such thing as clean coal. About 20% comes from nuclear energy, And the remainder comes from a variety of sources: hydroelectric, geothermal, solar, and wind. But what happens when we flip that light switch? Well, we expect the light to come on immediately, right? But the electrical grid actually has very little energy storage for direct electrical energy storage. We can store huge mounds of coal, we can store natural gas in tanks, but we're not very good at storing electrical energy itself. The US maintains a strategic petroleum reserve, about 700 million barrels of oil. That's enough if we were to lose all our ability to produce domestically, all our ability to import oil. That's enough to last for 45 days. Our electric storage capacity, about 30 minutes. So when you turn on that light switch, what happens is the grid operator injects a little bit more natural gas in the gas turbine, it spins a little faster, generates a little bit more electricity, and the light comes on. Our utilities have to, because there's no storage, our utilities have to match their production to consumption. And they do that all the time. That makes it really hard to bring wind and solar onto the grid, doesn't it? Wind and solar aren't always there. If we don't have a way to store them efficiently, then they're of little use. Most of it goes to waste. So it's really hard to incorporate it onto the grid. So how much electricity do we use? Globally, it's about 21,000 terawatt hours per year. Nobody knows what a terawatt hour is. But you probably know what calories are, more or less. So I converted it for you. I don't know what that number is, but it's big. It's really, really, really big.
Okay, so he puts the number on the screen on his slide. That is 30 with 15 zeros after it. So I looked into it. You know, 9 zeros is a billion, 12 zeros is a trillion, and quadrillion is 15 zeros. So it's 30 quadrillion calories. Which is a ridiculous number, and it's hilarious to see him do that because we do this on our podcast. We try to frame things in another light to make them useful to our listeners and to conceptualize them. Yeah. And we were against using analogies in some cases because they don't fulfill the whole picture. And he attempts to do this, but it's almost in a backward sense. Like, what does it mean to have 30 quadrillion calories?
Nothing.
That's what that means. But pretty jokes. And he, that clip there is just a setup. He said a lot of things we've already covered on this podcast about the current state of what is the energy grid in the state in the U.S. made up of in terms of the different proportions that are allocated to coal, natural gas, and nuclear. And he also outlined what are the realities of trying to store energy and what is the current situation. I thought he brought up some new information about the reserves the U.S. had that I was unaware of, about them stockpiling basically X number of barrels of fuel and coal so that they can basically power for 45 days, which was interesting. But other than that, that was just the beginning of this clip. So he continues in the next clip, but if you have something to say, go ahead and jump right in.
Yeah, no, I think the flow battery concept is pretty interesting. My questions, though, are in relation to the chemical. So if we're talking about a chemical that's not harmful, I'm looking at a list right now and I don't know if any of these fulfill that criteria, or because ultimately we still have to mine for these salts, right? If it's a bromide salt, we still got to mine that salt, right? And to make a solution, it's a mixture. So we got to mine stuff independently, come together and mix it into one nice little concoction. So in terms of the environmental benefits of it, I'm unsure of from that side, just because of the actual components of the salt or of whatever it is, because ultimately it needs to be mined. So that just goes back to mining. But then maybe environmental benefits from load stabilization, which would be reducing the waste of energy and electricity. So those are, of course, environmental benefits. But I'm also looking at, for example, flow batteries normally considered for relatively large being 1 kilowatt hour to 1 megawatt hour of stationary applications. So that's a very low amount. Like if we're going to incorporate these flow batteries, 1 kilowatt hour to 10 megawatt hours, that's not a lot. That's very little.
You know what? And I don't have the numbers in terms of what are the specifications around this guy's concept of flow battery. In the previous videos, though, there was that company, Form Energy, that specifically was trying to advance it beyond what you just gave me there. So there are people that think flow cells can fill the gap of this grid size energy storage. Now, can that be done with the same chemical makeup that this guy's suggesting? I don't know that, and I don't even know if it's necessary that he's saying that it's not I might have misled you there by saying that it doesn't have to do with mining. It's more that it doesn't rely on lithium, cobalt, or lead, which are common battery components that are just they have their environmental impacts. A lot of substances, even naturally occurring ones, have their environmental impact, even in it just by the nature of concentrating them and or exposing them to the surface. That's all there. But it's just like, okay, if we could have an alternative out there that didn't rely on lead, lithium, or cobalt, that was a flow cell that could be used for grid size. That's interesting.
Could have some benefits. Yeah, because of course, iron. There's issues when iron gets into, for example, water, and it gets into contaminating food sources and all the neurodegenerative issues that come with that. So, of course, those are things that we want to avoid too.
For sure.
When it comes to those heavy metals, right? But anything else on that before we move on to the next clip?
No, let's jump into the next one.
Okay. You want to set up actually the next clip real quick?
Oh, it's a continuation of that TED Talk.
Okay, just a continuation. Okay, let's go in.
Like I said, it's going to double in the next 25 years. How are we going to meet that demand? Well, let's just burn more stuff, right? I have a little bit of a problem with that. And the problem is that anytime we burn anything, we emit carbon dioxide and it goes up in the atmosphere. And most of you probably recognize that leads to climate change. On the right is a dynamic plot of average global temperature since the year 1850. As that circle gets larger, that means it's getting hotter. You'll notice when it reaches present day that it gets pretty hot. And in fact, the 4 hottest years on record, anybody want to guess? 2015, 2016, 2017, and 2018. Coincidence? I don't think so. But if you're a skeptic, and maybe you don't believe there's a connection between the plot on the left and the plot on the right, let me pose this question. Wouldn't it still be better if we didn't burn so much stuff? Let's save the stuff we can burn for where it's most efficient, like for generating heat. We've got lots of different ways we can generate electricity, many of them better than burning things. So let's come up with a new plan. Our new plan is going to be a 5-step plan. We're going to have an enormous power plant. And let's make it a nuclear power plant. Ooh, silence. Maybe you don't like nuclear power. It's pretty clean, actually. The real reason that you don't like nuclear power is because you don't want it near you. So let's do it far away. And let's use fusion instead of fission. So let's put it very far away, let's say Kansas. But I have relatives in Kansas and I still like a few of them. So let's put it even further away. Let's put it 93 million miles away. Fortunately, there's already a big nuclear power plant 93 million miles away, and we call it the sun. Let's convert that nuclear energy to electromagnetic energy. It's just a fancy term for heat and light. And instead of running an extension cord to get that energy, let's beam it to the Earth in the form of heat and light. So Mother Nature's already taken care of the first 3 steps in our 5-step plan. Pretty good, huh? Step 4, we need to convert that to electrical energy. We already know how to do that. We have solar panels that work pretty efficiently and convert sunlight directly to electrical energy. And in fact, in many areas of the world today, it's cheaper to generate electricity from solar power than it is from natural gas or coal. Cheaper. Problem is, it's not always available when you flip the switch. So we need that last piece. We need that storage. Remember I said we need energy? We also need energy storage. So let's convert that electrical energy to chemical energy for storage. How are we going to do that? Well, how about a battery? Batteries are great, but they're kind of expensive. And they also have some nasty things in them. We need a new battery, and it's got to be really, really cheap. And let's get rid of the nasty stuff. So let's not use lead. That's horrible in the environment. Let's not use lithium. That lithium mining is horrible. Let's not use cobalt. Cobalt's mined by 10-year-olds in the Congo under unsafe conditions. Let's get rid of all that. And let's use organic materials, all organic materials, maybe a little water and a little salt. And then let's model our new battery after something that we know very well and has worked very well for over 100 years. The engine in your car, the internal combustion engine. You guys think I'm nuts. And that may be, but the test results don't come back till Friday. But hear me out. If we model it after the car, we can make a battery that stores chemical energy in the form of liquids in tanks, just like the gas tank in your car. It's pumped to a central engine. In this case, the engine is an electrochemical cell rather than the true engine that you're more familiar with, rather than an internal combustion engine. And that electrochemical cell can now convert our chemical energy into electrical energy directly, cleanly, without CO2 emission. We've removed combustion from the internal combustion engine. Is this a pipe dream? Actually, these already exist. We know how to make these, and they work. They're not perfect, but we're striving to make them perfect. And I envision a day in the not too distant future where we have these giant batteries located next to solar farms. Solar farm collects the electrical energy, we store it in the giant battery, which might be as big as this entire building, and then it's distributed out onto the grid to everybody who wants it. Well, almost everybody. What we're also working to do, and this is the cool part, we're working to make them smaller and cheaper, small and cheap enough to power small communities and even individual homes. And that way, we can disconnect from the grid entirely. We don't have to run the wires to every home that's 600 miles away from the nearest grid point. That gives us a way to finally bring 100% reliable solar-derived power on a 24/7 basis to those 1 billion people that didn't have it 15 minutes ago. Thank you.
And that is his sell pitch. But there's a lot in there to discuss. One of the things is the concept of basically decentralization and moving off grid. We've discussed in other podcasts the cost of trying to build the infrastructure for the renewable energy, then build the transportation and tie-ins of the renewables into existing energy sources is expensive, and it is using a concept of just like trying to tie in new technologies with old technologies, and that works because we know the old technology worked, the old grid system got energy to the right houses. But what I wonder is it possible to, in this transition, develop more of these off-grid locations that reduce the amount of cost that is associated with building new grid networks? So that was one part of his discussion, which I think was worth investigating more.
I'll continue off what you were saying. So you were talking about so when it comes to decentralizing the grid, which is what that guy ends off of, I think that's a great point that you brought up, that it is an interesting thing to think about, because decentralizing the grid it's kind of like this pipe dream that you have these freaking hippies or people that are trying to go off grid or like, yeah, fuck you, man, I'm gonna go off grid, whatever, right? But it comes from this idea of moving away into an independent system. So let's just talk about that for a second, because what he's talking about right there is a whole different ball game that now you're trying to bring into play. Right, we have a centralized grid for a reason. One of those reasons is safety and security. We don't want, well, traditionally, historically, let's say, they historically didn't want to have all these different sources and inputs because that meant that things were outside of control for safety purposes. Now, maybe it wasn't for safety, maybe it was just for control in one centralized location, whatever. We want to get into those debates. But regardless, there are concerns when you're moving from centralized to a decentralized distribution with regards to your power. So just as a reminder, we have centralized power stations that kind of link to a centralized grid. But what this guy is talking about is decentralizing those power units by, I guess, having more photovoltaic, more solar, having personalized flow cells that link to these batteries, which would fundamentally move you away from the electrical grid.
Well, hold on, because I put those words into his mouth. If you listen to the context of it, when he's talking about the off-grid stuff, he actually began at the beginning of the TED Talk, which wasn't clipped here, about there's 1 billion people that don't get reliable energy, and the reason they don't get reliable energy is because they're so far away from the power source that they don't run the power lines out there. So when he addresses that last bit, it was kind of to close off. I don't think he's talking about a massive overhaul of decentralizing the grid. That was something I brought up. But he's talking about more that this technology, like a small-scale nuclear reactor, is a potential to solve the power reliability issues in those remote locations. So just before you go off too far, like he's saying, I know, and I understand why you need to have centralized systems, and especially for cities, it would make absolutely no sense with the high population density and footprint that's taken up in cities to have individual energy productions throughout there, and the safety concerns around, like, building goes down and blows up some battery or something like that on a building, and what is the potential risk there compared to having the actual generation plant outside the city, and then you just bring the electrical in on lines and stuff like that. I get that.
So are you saying he's the 1 billion that he refers to, is that just people that are living in like impoverished areas that don't receive electricity at all? Is that what he's saying? He's going to bring power to them with this?
He's saying it's a impossibility, yeah.
Right. But I think he's saying both, though. I think he's saying that, right? He's saying, okay, we're going to deliver power to these not off-grid, but to these hard-to-reach locations. But to me, it sounded like he was also talking about moving away from decentralizing the grid as well.
I don't think so. I think
because at the end of it, that's kind of isn't that what he said? Like about decentralizing the grid.
He brings up the the decentralization was. He didn't even use the word decentralization. That was purely me talking at the end there.
No, I literally wrote it down. I made a note of it because he talked about it. Maybe not. I don't know. Because like I was taking notes as he was talking, and it was like decentralizing the grid.
I wanted to close this off, discussing a current event, and that is Elon Musk becoming the richest person in the world right now, surpassing Jeff Bezos.
Yes, sir.
Is quite a landmark. The Tesla CEO is now worth an estimated $194.8 billion, which is $9.5 billion more than Bezos. Which
that's gotta hurt.
That's gotta hurt,
that's
man.
Gotta sting the ego.
you got all those Amazon, stores across the world. The lockdowns are helping them. Everything's going great for you. What's going on?
Everything's going your way, man. You still freaking lost the lead. Jeez. Hey, props to Elon, man. Man's hustling. Right?
The man is hustling. In fact, let me highlight some of the stuff. I know you and I know a lot about his projects, but this guy is doing... he has Tesla electric cars, but under Tesla, he has also a project called Solar City, which really looks at building these wind and solar. For Solar City, mostly wind, for mostly solar panels combined with energy storage in the form of lithium-ion batteries. And earlier clip mentioned the largest lithium battery energy storage plant in the world was built in Australia. So he has, Tesla has designed different size products for this. So they have the Powerwall, which is for your home battery. They have the Power Pack, which is for commercial scale batteries, and they have the Mega Pack, which is designed for utility scale installations. And so he's got the electrical car market. Okay, he's got the solar panel market. He's got the boring company, which is drilling holes underground to alleviate traffic. He's like, oh, you know what? Flying cars are dangerous. They could fall on your head. They crowd up our skies. Let's make a network of holes under the planet to have cars drive around. He has the Hyperloop, which is specifically a fast train rail system that's capable of traveling, I think it's at 800 miles per hour with reduced drag. And I think the focus of it is travel between Los Angeles and San Francisco. He's got Neuralink, which is literally trying to connect the human brain to a computer. He's got SpaceX launching, making affordable rockets, making space travel a possibility. He wants to get to Mars. And within SpaceX, he has the Starlink, which is the 40,000 satellites that are going to orbit the planet to give everybody free internet. So this guy's got a lot of irons in the fire there, and he's he's an interesting character. And the reality of this world is, those that hold the money is where the projects are going to be, are going to control the projects, going to control our future. The Bill Gates, the Jeff Bezos, and the Elon Musk of the world, and the things that they fund are going to likely be shaping our future, whether we like them or not. And I find Elon a curious character. He is like this version of Tony Stark, but in real life. And, whatever you think about space travel is a weird one because we're an environmentalist, podcast. We're worried about safeguarding this planet and the environment and stuff like that. And the pursuit of space has environmental impacts. And arguably, I've always said, I've had the idea, if you're looking to populate Mars, it's almost in the concept is like you've given up on Earth in a sense. But this is not, these are my own opinions. But one thing about going to space, which I think is extremely important, is it gives us perspective. It gives humanity perspective. And in a time when we are losing our ability to look at the night sky because of light pollution in cities and really think about what it means to be on this planet and the finite of our resources, it's quite amazing. And I recently saw this video, which was posted on by ISS, the International Space Station, which was an interview with an astronaut. This was put out this year, January 1st, 2021, and the astronaut they interview is Colonel Benjamin Alvin Drew. He's a United States Air Force officer and former NASA astronaut. He has been on 2 space flights. The first was the Space Shuttle mission STS-118 to the International Space Station in August 2007. And again, Drew's second space flight took place in March 2011, and it was on the STS-133. and it was another mission to the International Space Station. But I wanted to play a clip from him because I thought it was a very interesting way to think, and we need more of this.
I only have 7 clips.
It should be number 7.
Oh, right.
I did not think the experience of spaceflight would change me. And I hear about these people having this overview effect, and they come back and like, what am I going to go experience out there that's going to change who I am? But it made me think about a lot of things. And so for the first part, we all had that part where you're seeing the Earth, and you see yourself next to the Earth, and you feel very tiny next to the Earth. Then you turn the other way, and the Earth seems very tiny compared to the cosmos out there. And so you feel like you're 2 orders of magnitude down in terms of the size of things out there. All of life, all of the history of life, all of your life, and everybody you know is in this little tiny membrane of air that sits on top of this planet. And beyond that membrane of air is this abyss of space. It's just, there's nothing life-giving about it. And that's it. That's all that separates you. And it makes you feel like we're in a very tiny spot out here. As big as the Earth seems, it seems suddenly very, very finite.
Mm-hmm.
Yeah, I listen to that, and I think it's a very important message to always remind ourselves about this, because, as he put it, as the TED Talk mentions, whether you believe in climate change, like the relationship between CO2 and the possibilities there or not, he talks about, just let's focus on burning things where they can best be used, and what is the harm of diversifying our portfolio of energy generation. Even in that sense, that in an effort to maintain, to sustain what we're doing on this planet, which is incredible, this little membrane on this rock, for generations to come, we gotta take care of it, so I think there is, the need to, when you look at space, there's just the need to put aside, these petty things about, this is, I want to win the argument, I want to da-da-da-da. Like, at the end of the day, there needs to be a realization that, if this can provide some good, and that good, is going to be good for you, your family, and the rest of the world, and it's going to help us humans live longer, better lives, then we should pursue those things. But there are some things that we just need to be cautious about as we're pursuing them, that they don't do the opposite of what they're advertised to do. And that's something we've been talking on this podcast about, and we'll continue to talk about those topics.
Yeah, I think it's critical to think of it like that, because sometimes we can have these solutions that we think work, but in reality they might not, and we need to be just mindful of that. What got us from point A to B might not be what gets us from point B to C, and these energy kind of, we talked about this before, but yeah, energy is a complex game, and we need to be mindful of what's done initially for good intentions. Even though it starts off with good intentions, how many times does that happen, where it starts off with the right intentions in mind, right? We're doing this for environmentalism, we're doing this for the planet, we're doing this for future generations, but then the idea gets hijacked by a corrupt few groups of people, and they misuse the good intentions of the idea and the good intentions of the people that generally want to make some differences from these fundamental ideas, but then they take it, skew it, misuse it, and really pervert it from its original state. So it's just something to also consider in this discussion. Moving towards the good is good, but who's deciding what's good, right?
Right.
There's that moral dilemma over here.
Exactly. And you know what? We're not going to get it right 100% of the time. And it's not even important that you agree with us 100% of the time. What's important is that we highlight that there are different ways to think about this and other considerations that need to be brought into the conversation. And if you walk away from this podcast and the only thing is that you've learned something new that allows you to listen to a solution that someone's putting for you and go, okay, that's good, but I actually know this about it, and what about this, and have a clearer understanding of what these things that you might be asked to vote upon or support, as new governments come into play, new policies, you will be more informed to help guide us in a direction that all humanity in a direction that will have a better outcome, I think. And so, yeah, again, we're not going to get it right 100% of the time. You don't need to agree with us, but I hope you learned something from this podcast, because that was one of the key points here.
Yeah, we're trying to learn at the same time, and hopefully by us learning, we're just trying to share what we're learning, and maybe you guys can find some value in it too. I think that's ultimately what it comes down to. I want to push back on you though and say I don't know if I would describe this as an quote unquote environmentalist podcast, but rather we look at environmental subjects and try to analyze them from first principles, because those are the things that interest us, right? We studied environmental engineering, we studied that kind of stuff because it's what tickles our fancy, for lack of a better term. But whether it would fall under the term of environmentalist, I don't know.
No, I would say we are, in a way, like we're anti-environmentalists in a sense. Like as a hero, opposite hero is a villain, then they're anti-heroes.
Yes.
But if you were to tag our podcast, I would think a lot of people might tag it as an environmental podcast.
Right.
But I do see the distinction. And that's part of the nuance that we try to highlight.
Exactly. Screw them. They can point their fingers. They can think what they want. We know what it is. We know what we are. Screw them all, Pinky.
Here.
Okay, we talked a lot there. Any final points on the podcast there before we wrap things up?
You know what? If you like what you're hearing, on whatever app you're listening to this on, if you can write a review, give us a thumbs up, please do. It means a lot to us. Also, check out our website. What's our website again?
firstprinciplespodcast.com.
That's it.
You can find us there, contact us, and if you have any questions, feel free to email us there, and we'll contact you back, give us a response, and if you have suggestions, by all means, send us those as well.
All right, everyone.
Catch you later. Peace.
Peace.